Good morning, sir.
Good morning to all of you.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Morning, sir.
Good morning, sir.
Morning, sir.
Am I audible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So today being the first class, let me first give you the introduction about the subject, and then we will proceed according to the different topics. So the name of this subject is Material Science and Engineering, as you all know, and this is a very important subject. Now, why it is important? As you know that without materials, we cannot think of anything. In fact, in everyday life, everywhere, in every aspect of human life, material is so important. Historically, if you look, the development and advancement of societies have been intimately related to the members' ability to produce and manipulate different types of materials to fulfill their needs. In fact, the early civilizations have been classified according to the use of materials. As you all know that we call a human age, civilization, one particular civilization as Stone Age. Why it is called Stone Age? Because the early people, when science and technologies were not so much developed, they used to use only the available materials at the time, mostly the stones. So that is why it is called the Stone Age. So that time people used to use the stones only. Apart from stone, of course, other materials, but mostly stones. They used to make different types of weapons, to hunt different animals, to collect their food. So that is why Stone Age. Then comes the Bronze Age, or sometimes we call the Copper Age. So slowly what happened, according to the development of human civilization, and the use of materials, the different names were given. So Bronze Age, then Copper Age, then comes the Iron Age, and in modern times we say Electronic Age. And further development is taking place of materials, because you know that almost every day new type of materials are being developed to fulfill the need of human beings. So it is the use of the materials and manipulation of the materials which is important. And you can think of any engineering device, and mostly will be concerned about the engineering materials. So if you consider any engineering materials, any engineering device, you cannot think of any engineering device without material. You take a very powerful device. Let us say you are considering a chip in the say computer. It is made of mainly materials, although there are a lot of science and technologies involved in that. But mostly the material, without material you cannot do anything. So if you look around you, you will find thousands of different types of materials. Why different types of materials? It is because the materials have got different structures, and there is a structure property relationship. So that is what we are interested in. We will try to understand the different structure of materials and how the structures affect the property of the material. That is the main component, main thrust of our discussion. So materials are probably most deeply connected in a culture than we can think of. You can think of transportation, housing, clothing, communication, recreation, everywhere. Everywhere materials are used. And the early people, as I have already told you, the early people had access only to limited materials. Because the science and technology were not developed to that extent, so they could not manipulate the materials using the knowledge of science and technology to fulfill their need. That is why they used to use the only naturally available materials at the time. Now, as the time progressed, with the passage of time, what happens is that there were development in science and technology, there were development in manipulation, different manipulating technologies, different processing technologies by which they could transform the materials into different form to fulfill their needs. So newer types of materials are developed. And you can now think of the most modern types of materials we will see different classifications of materials. You will find the materials which are called the advanced materials. In fact, you can think of more, newer types of materials in the coming future. So there's no limitation of development of materials. And so it's a very, very important subject. As an engineer, you must know some of the basic properties of materials. Being mechanical engineer, you may be interested mostly to the materials used for designing different devices in mechanical engineering. And there also you need to know the basic properties of materials, because considering the engineering aspect, you may design, considering the load, stress, strain, etc. You may design a material, but ultimately you have to select the material, because the component or the device will be, manufactured with the help of the material. And finally, the selection of the material, considering the different properties, plays a very important role. So that is why you have to know the material. So mostly we'll be concerned about the engineering materials and their properties. So we'll go one by one, but today, being the introductory class, I will just give you some basic information about the subject, its syllabus, and some basic concepts about material science, materials engineering, materials classifications. So these are some of the points I'll be discussing today. So what I'll do, I'll directly go to the presentation. I will present some slides. And I request to your CR, Sandeep, to record the class, or anybody of you can record the class, and I want a copy of the recorded version. So, okay, today being the first class, no problem. You can record from today onwards, or tomorrow onwards, next class onwards also. So you can start recording also from today. So I want the recorded version of the different classes that I will be taking. So Sandeep, can you hear me?
Yes, sir.
Okay, so you or anybody of you can record the
Okay,
class.
sir.
So let us come to the point. So I will go directly to the presentation. So just see whether you are able to see the presentation. Can you see the slide?
Yes, sir. Yes, sir.
Yes, sir.
So let me enlarge the slide. Okay. So material science and engineering. Myself, Professor Buddhadeb, Professor of Mechanical Engineering. I am with this department, it is about for 27 years. So you can, if you are interested, you can see my background in our website of our department. So I am teaching this subject for quite a few years now. So this is the syllabus, material science and engineering. Let me give you the overview of the syllabus. As I have told you that structure of the material plays an important role in deciding the property of the material. So if you are interested to know the property of any engineering material, you must have to have some idea about the structure of the materials. So under structure, we'll just glance through some of the topics. Although these topics you have studied at your plus 2 level, but some of the basic points we'll be discussing, like crystal structure of materials, crystal system, unit cells, space lattice, Miller indices. This Miller indices probably is the new topic to you. Miller indices of planes and directions, packing geometry in metallic, ionic, and covalent solids, imperfections. This imperfections is very important. What are the different? In fact, what happens is that the perfect material may have some deficiencies in required properties. So what happens is that we intentionally deform or make the material imperfect. We intentionally make the material imperfect to improve their properties. So we have to study the different types of imperfections. What are the imperfections which are beneficial to us? So all those points will be discussed here. Now diffusion process is a very important process by which we can manipulate the material to change their properties. So we must have to study the diffusion process a bit detailed. Then as mechanical engineer, you must be interested in different mechanical properties in detail. In fact, you will be carrying out, or you must have carried out some experiments in your applied mechanics lab to know the basic properties, basic mechanical properties of materials. So like basic stress strain diagrams of metallic materials, modulus of elasticity, yield strength, tensile strength, toughness, elongation, plastic deformation, viscoelasticity, hardness, impact strength, creep, fatigue, ductility, and brittleness. Now, point is that you must have to know each and every mechanical properties and the process by which you can evaluate the mechanical properties. That is important. Suppose if I ask you how to evaluate the toughness of the material, you must be in a position to answer, or you must know what is toughness and how toughness is evaluated. Suppose if I ask you what is impact strength, what is creep and fatigue, I will decide the fatigue life of the material. That you must have to know. So we will discuss each and every mechanical properties in detail, considering of course the time limitations, because you have also the limited time. So depending on the available time, we will be trying to discuss these mechanical properties and their evaluation. Then electronic properties of the material, of course, is very important. As you know, the present age is the electronic age, because there are a lot of transformation being taken place in the materials electronic properties, and thereby we are getting advanced materials, advanced computing devices are being developed. So electronic properties should be known. Concept of energy band diagrams, conductors, semiconductors, insulators, electrical conductivity and their temperature effect, intrinsic, eccentric semiconductors, dielectric process. These are some of the points, of course, known to you. Some of the basic points. We will try to discuss some more extensive, some extension of those concepts. Then very important is this metals and alloys. Very important, because as mechanical engineer, you will be mostly using most of the metals and alloys for designing different components. So you must have to know some of the basic or important extensively used metals and their alloys, their compositions, their properties, how the properties get changed depending on the composition. So some of the topics like solid solution, solubility limit, phase rule, binary phase diagrams, intermediate phases, intermediate compounds, iron carbide phase diagrams, heat treatments, cold and hot working of metals, recovery, recrystallization, grain growth, microstructure, properties and applications of ferrous and non-ferrous. This ferrous and non-ferrous materials, some of the ferrous materials are very extensively used, so you must have to know those ferrous materials. You must have some clear idea about those ferrous materials and some of the non-ferrous materials. Then comes the ceramic materials, polymers. Of course, here you see there are some, these topics have been included based on the classification of materials. Of course, we'll be discussing the classification materials. Now, at this point, let me tell you, if you consider any engineering materials, we are not considering at this point biomaterials or bio materials which are used in medical field. Rather, we will be concerned about the engineering materials. So, if you look around, I have told you that you will find 1,000 different sets of materials, but at this point, we will, limit our discussion to engineering materials only. So, if you consider the engineering materials, the engineering materials are classified. Engineering materials are classified into some categories, like these metals and alloys are one category. Then comes your ceramic materials. Then you have got the polymeric materials. Then you have got the composite materials. Then you have the semiconductors as one category of materials, and where the electronic properties are very much relevant for semiconductors. Then some of the biomaterials, not in detail, but some biomaterials will be discussing some of the biomaterials, and of course some of the advanced materials, like introduction to advanced materials and different tools of characterization. So this syllabus has been actually framed considering the engineering materials and their classification. So as we will proceed, topic wise, we will cover almost all the engineering materials and their properties, their usage. So this is how the engineering materials are classified. Now everybody should join in time. Now you see, in between, if you join, then it becomes a problem. So everybody should join in time. See, somebody are trying to join after 25 minutes, no point. Okay. So next day onwards, today I will just allow him to enter. Abdul Wahid. Wahid. Can you hear me?
Yes, sir. Yes, sir.
Abdul Wahid. So why
Yes,
are
sir.
you so late?
Sir, my network problem, sir.
Network problem. Anyway, of course, there are certain problems to some students because they are staying in remote areas. But for us, it becomes a problem every time. One by one, if tries to join, then I'll have to continuity of the discussion is hampered. So you try to join in time from next day onwards. Okay.
Okay, sir.
Okay, sir. So, metals and alloys and ceramic materials, one type of materials, and we'll discuss about the structure of ceramic materials, their properties, processing, application of traditional and advanced ceramics. Then polymers, of course, polymers you have studied at your class 2 level. We will discuss here some of the polymeric materials, their uses, their properties, and their processing also. Then very important type of material known as composite material. Probably this material is new to you. Composite material. This is a very, very important material. If you take one particular material, then that material may not have the required properties, all the required properties. Then what we do, we try to mix two or more materials, so that superior type of properties can be developed in the material, and that material can be used to fulfill our requirement. So the idea of composite material is this, that you try to mix the different materials to get the required properties. So we'll discuss about the composite materials, and there are certain techniques like powder metallurgy. very extensively used for developing new types of materials with advanced superior properties, and how the composite materials and their properties are determined, that also we'll be discussing. Then we'll give you some introduction about the advanced materials and different tools for characterization. And in these advanced materials, you have smart materials, piezoelectric, ferroelectric materials, optoelectric materials, nanomaterials. Nowadays, lot of research is being carried out in nanomaterials, because if you reduce the size of the material, the property of the material is improved. How it is improved, we will try to give some idea. Then synthesis of this type of materials and their properties and applications. Then biomaterials, then some materials called the super alloys, shape memory alloys. Then material characterization technique. Now, okay, we have developed, say, different materials, but how to know the different properties of the material? What are the characterization techniques? Characterization techniques means the evaluation of the different properties, measuring the different properties of the material. So, environmental degradation and corrosion, oxidation of materials. Of course, materials gets degraded with the passage of time. So, how to reduce the degradation of the materials and how to prevent the degradation, that will be the point of discussion here. So, this is the syllabus of the material science engineering subject. Next, some of the reference books. Here I have given you the 4 reference books. Now, point is that the syllabus that has been framed here, one particular book may not cover all the topics. That is why some of the topics will be see from some of the books, different books. So, first book here, Material Science and Engineering, an introduction by William D. Callister and David G. Rethwich. Second book, Foundations of Material Science and Engineering by William Smith. Third is Engineering Materials and Their Applications by Richard F. Flynn and Paul K. Trojan. Number 4, Material Science and Engineering by V. Raghavan. So first, if you take first 2 books as a reference, it will be, I think, sufficient, and you can get almost all the topics. And if you do not get any particular topic, you try to see some other. So many books are there. So you take 1 or 2 books as reference and try to study the different topics. Okay. So some basic idea about the difference in material science and materials engineering. Being engineer, we will be mostly concerned about the materials engineering. So let us try to understand the difference between material science and materials engineering. So material science is defined as the study and investigations regarding the structure, property, and structure property relationships of different materials without being concerned about the immediate use of the material under study. That means the material scientists, they go into the deep of the material, and they are not that much concerned about where the material will be used. So, lot of investigation science, lot of investigations are carried out on the materials regarding their property structure and their property structure correlation. But the material scientists, they are not that much concerned about the immediate use of the material. Like example can be the various branches of physics and chemistry, like solid state physics, physical chemistry, like solid state physics, let us say. They go on studying the materials so far as their structure, property correlation. And I can give you an example. Like we have got just near Jadavpur University, we have got the Indian Association for the Cultivation of Science. They have also different facilities for carrying out the research in the area of material science. You know what they do? They mainly carry out research to study their structure, property, and their other various aspects and they are not that much concerned about the use of the material. So they are actually called the material scientists. On the other hand, if you see the materials engineering, or what are the role of materials engineer. So first we have to see what is material engineering. Materials engineering is defined. I'll give you one example so that it will be clear. Materials engineering is defined as the study and investigations regarding has been written 2 times. It should be omitted. Study and investigation regarding the structure, property, and structure property investigations of different materials for design and development of new materials with predetermined set of properties, so that the developed materials can be used for specific applications. Let me give one example, it will be clear. Like in material science, we have given one example, let us say solid state physics and different branches of chemistry and the work they are doing. I mean, in materials engineering, let me give some examples, like development of cutting tool material. It's an example of mechanical engineering. Then development of different semiconductors. Then development of composite materials, development of nanomaterials. See, development of nanomaterials basically with certain predetermined set of properties definitely is the role of material engineer. Material engineers. Say, development of cutting tool material. This is a very relevant example, very good example to understand the material engineering. A cutting tool material, you will be very much, you will be acquainted with this cutting tool material. Probably you are not, okay, in the first year, you were given some exposure about the machine tool lab or machine shop. We have got a machine shop, name of the machine shop is Blue Earth Machine Shop. So there you will find a number of different types of machine tools, and in those machine tools, what I do, we convert the raw material into the finished product by performing different types of machining operations. And while performing the machining operations, what we require is that we require cutting tool to cut or to perform the machining operations. And ductility also, and other mechanical properties, so that they will be in a position to cut the materials you are going to if it is, you can consider this as a forward path. But and you see, in the material science, what we do, we take a material, we perform different types of investigations on that, we try to know the structure, we try to know their properties. So finally, after investigating the material, we are in a position to know some of the properties. On the other hand, material engineering is a backward process. We must have to first determine what are the predetermined set of the properties the material should have. So you first have to know what are the different predetermined set of property a cutting tool material should have. So you must be told in your machining technology classes or machining some subjects. There are certain subjects from production specialization where you will be taught about the different properties a cutting tool material should have. At this point, I can tell you a cutting tool material should have very high hardness. The material should be hard so that it doesn't break quickly. Then it should have very high toughness. So you must have to know what is toughness. So these points will be clear once we discuss the mechanical properties. So it should have toughness. Then this cutting tool material should have the high temperature resistance properties, which is called the refractoriness. High temperature, because when this cutting tool material will be in contact with the material you are going to cut, there will be friction and a lot of heat is generated. And if the cutting tool material doesn't have the proper hot hardness, it is actually called the hot hardness, the ability of the material to withstand the high temperature, it is called the hot hardness. The material should have hot hardness, and also these 3-4 properties are very important for a cutting tool material. So keeping in mind these properties, you will have to proceed backward to develop the material. So what are the materials which will have these properties? Now, it may so happen that you cannot find a single material which will have all these properties. Then what will you have to do? You must have to manipulate the material. You must have to manipulate. You'll have to see what are the materials, probable materials, which will fulfill the requirement, our requirement, predetermined set of properties. So you have to proceed backward. There comes the research and development. You see, the cutting tool materials which we are using nowadays, these materials have not been developed in a single day. A lot of research has been done on that, and slowly the advanced type of materials nowadays, you will find that one type of very extensively used cutting tool material is known as high speed steel. It is called high speed steel or HSS. There are other types of materials like carbon steels. Then you have got the ceramic tools. Then you have got the carbide tools. So there are different cutting tool materials, and these materials have been developed by conducting different types of research, and so ultimately we are able to develop a very high grade cutting tool materials. So this is an example of materials engineering. So it is a reverse process compared to your material science. Similarly, if you consider the semiconductor, you see earlier we had a limited semiconductors. Nowadays, when we'll be discussing about the different, we'll say particularly if you consider the N-type and P-type semiconductor, you just form the PN junction, then of course the transistor. Again, the transistor, NPN or PNP, they can be, modified, or instead of just silicon and germanium, the basic semiconductor materials, silicon and germanium, there are other the semiconducting materials, semiconductors, which has been developed with superior properties. And that is why you see, during our days when we are students in 80s, the size of the computer, and the computer were in the form of some completely different computing device. We used to punch cards for writing some programs, and the size of the computer were quite big. But you look now at this present age, you will find that there's a lot of developments. The size of computing devices are being reduced. It is because of the development of new type of computing devices, and of course their semiconductors, the semiconductor materials plays a very important role. So like that, a lot of developments are being taking place in all areas of material science and engineering. And as I was telling, the composite material, it's a very, very important area, and almost every day new type of in the world, every day research is being carried out to develop new types of materials, composite materials, or you call nanomaterials, apply these materials in a specific applications. So this is the basic difference between material science and materials engineering. Now some idea about the classification of materials. I have already told you the engineering materials. If you see the basic classifications, we classify into two main categories, metals and non-metals. Then under metals you have got the ferrous, non-ferrous, and particularly I will give more thrust on the ferrous materials because this is a material which will, as an engineer, you will be using quite extensively almost every sphere of life. Of course, non-ferrous materials are also used. Now, under this ferrous materials, you must have to know what are the different classifications of ferrous materials, the cast iron steels, classifications of cast irons, their composition, properties, uses, then steels, their classifications, compositions, uses. So all these are very, very important, particularly for you. You should have very clear idea because questions are asked from in the interview when you are going for an interview for job. You must have to have some basic idea about this ferrous material because mostly questions are asked from here because these are the materials which are extensively used. So you must have to have idea regarding the classification of ferrous materials, the compositions, their uses, their properties, basic mechanical properties. Solid solution of iron and carbon, we get the ferrous materials. Apart from the iron and carbon, what we do, we mix some other alloying elements like silicon, phosphorus, manganese, magnesium to improve their properties. But the main component is iron and carbon. You should remember iron and carbon, and we'll be discussing about the phase diagram, of iron and carbon, equilibrium diagram. Then we have got the other time temperature transformation diagram of ferrous material, and you will find how the composition of the ferrous material changes with respect to time and temperature. So, and also the properties gets changed. So there are a lot of points to be discussed about the ferrous materials in order to know about the ferrous materials. So ferrous materials, as I told you, basically classified into two parts: steel, cast iron. Cast iron has got different classifications. So here are the important points. Cast irons are classified as grey cast iron, ductile or nodular cast iron, white cast iron, malleable cast iron. So these are the grey cast iron, ductile cast iron, white. These two cast irons are very extensively used almost everywhere. You see any cast components, you'll find that this of ferrous material, you'll find that either it will be grey cast iron, ductile cast iron. White cast iron is not that extensively used, but it is also one type of cast iron. The white cast iron is very brittle. That is why it has got some limited use. Then you have got the malleable cast iron. So this is the cast iron. Then comes the steel. We have got the classification of steel. So low alloy steel, high alloy steel. So different classifications are there, and their compositions are also important. So compositions I have not mentioned here. The composition of iron and steel will be clear when we will be discussing about the iron carbon equilibrium diagram in phase diagrams. When we will be discussing the phase diagrams, it will be clear. Then comes the composite materials. So just one slide today about the composite material. Composites, as I told you, that we combine the different materials, two or more components or two or more materials with the composite material. Now the elements that we are going to combine, that can be in different form. One, actually in composite material, there are two main components. One component is called the matrix and another component is called the fiber. The matrix plus fiber makes this composite material. Now point is that the form of matrix and fiber can be different. Sometimes the fiber will maybe in the particle form, sometimes it may be in fiber form, sometimes it may be structural. So there are different forms of matrix and fiber. So depending on that also we have the classifications like particle reinforced. Sometimes the particles can be large particles, sometimes it will be small particles, very in the form around say atomic size particles. So it is called the dispersion strain. Then can be the fiber reinforced. We can reinforce some fibers of high strength into the matrix to get the fiber reinforced composite material. Then we have got the structural types of composite materials. These details we'll be discussing when we'll be discussing about the composite materials in detail. This is just introduction to give you some idea. Then classification polymers. So these classifications, I think you had some exposure about the polymers at your class 2 level. So you can just see this slide yourself. I'm not going to discuss about this. You can just go through this. This is just the basic idea about polymers. Then ceramic materials. Ceramic materials is another important type of materials because there are certain ceramic materials which have some exceptional type of properties. There are certain ceramic materials which are called the piezoelectric materials, piezoelectric ceramics. Let me give you one example. There are magnetic ceramics, there are conductive ceramics, there are different types of ceramic materials. You see, the piezoelectric ceramic materials has got a special type of property by which they can be the material can be used as signal sensing device. That means suppose you change the temperature. Suppose a ceramic material is kept at a particular temperature, and if the temperature is changed, temperature is increased or lowered, then what will happen is that there will be some changes in the ceramic material. That means it will sense the change in the environment. So it is used as a signal sensing device, and by that there are different types of transducing devices. Basically, transducer is a device which transforms one signal to another type of signal. So the ceramic materials are very extensively used as transducers, and why these materials can be used as transducers, that also we'll be discussing, and what are the different types of transducers, or what are the different types of what are the different changes in the ceramic material for which it can sense the environment, or it can change its shape. It can also change its shape depending on the change in environment. So those points we'll be discussing. Now basically ceramics, here we have two classifications: traditional ceramics and advanced ceramics. The traditional ceramics are just, as you know, the bricks, tiles, abrasive, refractory materials, cements, all these materials are ceramic materials. On the other hand, some synthesized ceramics or advanced ceramics have been developed. Like electroceramics, we have one classification, and advanced structural ceramics, we have another classifications. So these are some of the ceramic materials, and we'll give you some idea about the ceramic materials, their properties, their structures, their uses. So this is another important part. So another way of classifying the engineering materials based on their functions. where these materials, in which areas these materials are used. It can be used in aerospace engineering, biomedical uses, electronic materials, then energy technology, environmental technology, magnetic materials, photonic or optical materials, smart materials, structural materials. So there can be different classifications. But in general, the classifications which we have discussed based on their structure and properties. So this is another way of classifying, functional classification of the materials. Then, this is a very important point. We are discussing about structure of the materials, and I have already told you, because of the difference in the structure of the material, we find so many different types of materials around us. So structure starts from macro structure. The structure we see just with our naked eye. So this structure is called the macro structure. Then if you go deep into the material, you must have to take help of some devices to see the internal structure of the material. So you have got the microstructure, then phase structure, grain structure, nanostructure, crystal structure, molecular structure, atomic structure. Even you can think of the electronic structure and other types of structures. Now phase structures can be of different types, microstructure can be different types. So you see, when you are talking about the mechanical properties, here point to be noted is that when you are talking about the mechanical properties, the structures which will be more relevant to us are the microstructure, phase structure, grain structure, nanostructure, crystal structure. So these are some of the structures plays a very important role in changing the mechanical properties of the material. So you should have some idea about what are the different microstructures of iron and steel. How you see there are different types. We have already seen different types of cast iron, and you will find that these cast irons have got different properties, different mechanical properties. It is because their microstructures are different. We have metallography lab. We have one lab called the metallography lab. There we will try to understand the microstructure and the relation of microstructure with mechanical properties. How the microstructure changes, the mechanical properties gets changed. So this interrelation we must have to understand to know how the microstructure affects the mechanical properties of the material. So similarly, the phase structure. If you change the grain structure of the material, my mechanical property will get changed. Of course, nanostructure are there, but mostly, these structures, micro, phase, grain, nano, crystal, these structures are very important to know the mechanical properties of the material. So these are the different structures of materials. I have not included here the electronic structures. When we are talking, or when we'll be discussing about the electronic properties, the electronic structure will also be important. Now, the material properties. If you classify the material property, there will be a number of different classifications, starting from mechanical properties, thermal properties, optical properties. We have got the electrical properties, then technological properties, chemical properties, magnetic properties, physical properties. So, our main concern will be some of the properties like mechanical properties, electrical properties, magnetic properties, and physical properties. Of course, some of the physical properties. So not all the properties we will be concerned about, but mostly, we should give the maximum thrust to these mechanical properties of the material, because when you are going to design some component, you must have to know what is the yield point of the material, when the material starts yielding or starts deforming. So that is very important. So stress strain diagram and the significance of that is very, very important. That will be very, very important to you. So we'll be discussing mechanical properties in detail. Probably I will start with the mechanical properties first. Then the syllabus that I have shown to you. Not necessarily will be I'll be going according to the just written sequence, but there may be some change in the sequence of discussion of the topic. So in the next class probably I will start with the mechanical properties. You must have to know what are the different mechanical properties of the material and how you are going to evaluate the mechanical property. That is very important. You should be in a position after attending this material science engineering class, you should be in a position to define each and every mechanical properties, and also you should have idea about how to evaluate that particular mechanical property. So that is very important. So of course other properties, some of the properties will be required, but mechanical properties very important for us. Anyway, so mechanical properties, today I have another class from 11, so I'm stopping here today. So in the next class we will start from this point, mechanical properties, and we will try to understand each and every property and evaluation of each of these properties. Lastly, today I want to tell you that you see the way we are conducting the class under this critical situation, under this COVID-19 situation. It is, it is expected that there will be some deficiencies, some problems, like some of you are not able to join in time. And in the actual class, normal class, we used to interact a lot. Now, in this, remote, online form of class, interaction becomes a problem. Of course, you can ask some question. I will give you some, time to ask some questions if you want to ask me. Otherwise, interaction is a problem. Anyway, but still we can have some discussion. I will give you. We can have some, two-way mode of conducting the class. So we have no other option. We have no other option but to conduct the class in this form. Anyway, we'll try to have two-way discussion, not just one-way discussion. So today I just tried to give you some idea about this subject, the syllabus, the books, and other things. Some overview of different properties, materials, classifications. The next day we will start with the mechanical properties. Okay.
Okay, sir.
Okay, sir.
Okay. So next day is on which day? Thursday, Friday. Which day we have class? Another class. This next class.
I think Thursdays.
Possibly on Monday.
Mondays.
Not to me, right?
Okay. Thank you all.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you, sir.
Thank you, sir.
So I am closing. CR, can you listen to me? CR,
Yes, sir.
when they will send the attendance of students, I find here around how many students? 50,
49.
49.
Wait.
So you send me the attendance every day, okay?
Acha, wait, sir. I will take.
No, you not now, but you can
Achha.
send later on also. Not now.
Okay, okay.
Send me later on. And also, you send the copy of the video you are
Okay,
recording.
okay, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.